So today we're going to be taking the process that you learned yesterday and applying it to word problems. Whenever you have a word problem, obviously the first step is to read the problem. Second, you want to identify the two variables. Third, you want to write two equations that can be used to solve the system using elimination. 4, solve for one of the variables. 5, substitute the solution found in step 1 through step 3 into each equation to find the solution for the remaining variable. So I'm going to do the first 4 examples with you, I think, and then you're going to try the last 2 on your own. So number 1, we have the sum of two numbers is 36, and their difference is 24. Find the number. So in this one, it's kind of highlighted for you what the two equations are. So the first equation is the sum of the two numbers. So let's just say that those numbers are x and y since we don't know them. So x plus y equals 36 is our first equation. Their difference is 24, so x minus y equals 24. Now, this one's set up really nice for us because, as we remember from yesterday, we need a pair of opposite coefficients. And by having plus y and minus y, we have our opposite pair. So we can jump right into adding and eliminating a variable. So x plus x gives us 2x. Positive y and negative y cancels out. 36 and 24 make 60. Dividing by 2, we get x equals 30. Then all we have to do is plug that back in to get our second number. So x is going to be 30. We have 30 plus y equals 36. Subtract the 30. And y equals 6. So we have our two numbers being 30 and 6. And we can plug them back in just to prove that we've got it right. We know that 30 plus 6, the sum of them is 36. We know 30 minus 6, the difference between them is 24. So obviously we did it correctly. Okay, number 2. Emily has 18 coins in her pocket, all nickels and dimes, a value of $1.40. How many of each coin does she have? So we're going to go through again and make our equations that we need. So this part, this Emily has 18 coins, actually gives us one of the equations. And then we know they're nickels and dimes for a total of $1.40. So between those 18 coins, we know some of them are nickels and some of them are dimes. So I'm going to say N plus D equals 18. Now we have to add the value of each coin. So a nickel is 5 cents, plus a dime is 10 cents, for a total of $1.40. So now again, just like we did in the last one, we have to see if we have opposite coefficients, which obviously in this case we don't. So we could either multiply by negative 5 cents or negative 10 cents. My preference is to multiply by the negative 10 cents because it's just easier to do without a calculator. So I'm going to multiply the top equation by negative 10 cents and rewrite my system. So I get negative 10 cents N minus 10 cents D equals negative 180. Bring over my second equation, 5 cents N plus 10 cents D equals 140. And now we're going to use the process of elimination to solve for those two variables. So negative 10 cents N plus 5 cents N gives us negative 5 cents N. The 10 cents cancel out. And we're left with negative 180 plus $1.40 is negative 40 cents. Dividing by negative 5 cents, we get N equals 8. Think of it as 40 divided by 5. So we have 8 nickels, and we can plug that back in. We know if we have 8 nickels plus some number of dimes, we need a total of 18 coins altogether, minus the 8. So obviously we need 10 dimes. So our final answer is 8 nickels and 10 dimes. So I'm actually not going to do the next problem with you. I want you guys to come back to number 3 and try that one on your own. But I am going to skip to number 4 and try that one with you as well because it's worded a little bit differently. Okay, so jumping to number 4. Another scenario where we use the same process. Mrs. Kiesler went shopping for scissors and rulers for her class on Sunday. She bought 8 scissors and 12 rulers for a total of $36. So that's going to be our first equation. And Monday she went back for more. She bought 3 more scissors and 2 more rulers for a total of $9. That's our second equation. Find the price of the scissors and rulers. So from those 2 sentences, I can make my equations, and I know my variables are scissors and rulers. So 8 scissors plus 12 rulers for a total of $36. And then the next time she went, 3 scissors plus 2 rulers for a total of $9. So just like we've done the past couple times, we need to see if we can make a pair of opposites. So since the bottom one has the smaller numbers, I want to see, well, can I multiply something by 3 to make 8 or something by 2 to make 12? Obviously, I can make 6. I can multiply 2 by 6 to get 12, but I need it to be -6 so that they're opposites. So I'm going to multiply the entire second equation by -6. Rewriting my system, keeping the top one, and then replacing the bottom. -6 times 3 is -18s. -6 times 2 is -12s. And -6 times 9 is -54. Then we start eliminating a variable. 8s minus 18s is -10s. Positive 12r and negative 12r cancel out. And 36 minus 54 is -18. Dividing by -10, we get S equals $1.80. So now we want to plug that back in to get the price for rulers. So I'm going to plug it into my second equation. So we have 3 times $1.80 plus 2R equals 9. And 3 times $1.80 is going to be $5.40 plus 2R equals 9. Subtract 540. We get 2R equals, think of it as 9 minus 6. That's going to be 3, but then I need 60 more cents, so 360. Divide by 2. Divide by 2. And rulers are also $1.80 each. So both rulers and scissors wind up being $1.80. Okay, so you're going to make sure you go back to number 3, try 3 and 5, answering go formative questions as you go, and of course I'll be around to help you out.